Right. As we were talking previously, it is like the way as we were doing that things. It is like a class, right? And task here. So we just need to print it. Just remember in doing a very quick way as how Hacktor works, right? Just explaining that. So Hacktor in Swift is very useful because it gives you a great way, to handle the concurrence in a single way, right? So you just print it and says Hacktor, like a person, and put this value. Remember to put task and then sync our, right? That's the way as Hacktor work. So let's move on this, the initialite. So the initialite, it is the initialite is a let me explain. We have something that we call seek references cycles. References cycles, it could be one name, you know. We also have automatic references counter like this. What else? We also have another waves, all the things that the how memory. And also remember that the main things on computer is CPU, memory, and concurrent. Yeah, those three things are very useful because CPU, memory, and concurrent give you it's the only way as the computer runs there's value and also works with values, right? So um, when we have a references issue, we have to see if we can improve it using actor, right? When we have problem with CPU, we can check our graphic way as we handle our graphic uh, how can I say our our method and way as we act like this. We can if we have an issue with a CPU, we also see our algorithm. It's have a right. We have to implement better algorithms, right? But um, or more efficiencies, right? Like big O, right? Big O notation, big O notation, and something like that. But when we talk about memory, how we memory and how we can improve memory, we have to do improvement, in those three things, right? Um, yeah, actor like put it like this. But when we need to do some improvement in the memory, it's the topic that we are going to talk now. When if we need to improve our also the concurrent impact very high the CPU as well, right? So we can have, if we need to improve our something in our apps, we need to check, our very algorithm, big O, graphic, and actor, right? It means concurrence, right? But when we talk about just to not confuse, I'm going to remove it. Yeah. So a or concurrence, concurrent could be, yeah, but just to not confuse. And when we talk about memory basically points to this specific. We have memory, and memory is very useful, like as we says graphic, algorithm, big O, right? And memory has something that we call the initialite. The initialite, it means that you are going to remove the values that you have in your memory. So let's check how it's work. We have our we can continue talking about our person. Let's like something like this, right? So we also have in memory, to improve our memory, we can also improve like using something that it's called strong, weak, right? And we later we are going to talk about it. And we have also that called own it, right? We were then talking about it. So we have first yeah, we are going to remove it. And suppose that we have something that's called class apartment, right? We have apartment here, apartment. So one apartment um, could have a owner or tenants, right? And we can put like suppose that we have um, apartment, right? And says like the the tenants could be tenants, but we can put some person here, like a person, if it's used or also occupied, right, by one people. And we can also use something that it's called address. We can also specify the address, and we are going to initialize like this, right? And we says person is a person, right? We also ask address and string, right? We have something like this. And let's see, person equals to person, yes. And we also says address equals to address. Perfect. Yeah. And yeah, we have person that we are like says like a person is John. John has a his name, person like a name, John, right? So suppose that we have one apartment addresses. So here in my country, we can says addresses. Perfect. Okay. And says like this. We have addresses, address, and says, or we can talk like the apartment that we have here. It is um, 81 in New York. We can says like this, right? Apartment, and we says the name per the person is John, right? Who own or who is tenant on this apartment. And we also have address, right? And it is like let's see, this address on this apartment is New York. This is its address, right? So we can run it just to see what's going on. Yeah, it says the address, 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 right? Yeah, let's see. So we have address here, and it's correct, right? Let's see. Address. Okay, it's correct. So everything is fine. So if we have to, so remember and see that of the previous when we start talking about classes, we were talking about references. So remember that class impact very high on the memory. So we need to know how to manage it. So when you have a class and also John like this, we have John, and this information is floating on the memory. So we have our notes here, and remember that when we are running, when our apps is running, while the apps is running, we are occupating and using this memory, you know, and that memory will be used or could be used for another process and can and need to be released. It means like removed that memory. Remove the memory. Like this also, and remove that references. That's that I need to say. That references, you can remove that references, right? Let's copy just to very quickly give you our our example. Yeah, and remove that information, because sometimes, of course,